you can also look at it as the power of IFC5. The reason this one was made was to experiment with these connections. So if you look at this system connection 2, and there's a reference to a different unit. So this is systems in IFC4. How we're going to do systems in IFC5. The domestic hot water is trying to answer that with these, as you see, distribution ports have references to other paths. So you can imagine that if we do an import challenge or even an IFC5 software certification, these would be the typical things we look at to see if that kind of information is preserved. Georeferencing. This is relatively new. I don't think anyone has seen this yet. Did anyone see this? So, nice. So georeferencing in IFC 4.3 is, and also in 4, is super complex, overly complex, I would say. So we try to really simplify it and get it down to the core. So this map projection, for example, even with the scale factor, is causing so much confusion every time. But it turns out you don't really need that. So what you need is at least 2 points somewhere in the IFC5 file. So we have a point here and one here. And then we add in a certain EPSG code where that point is actually on the map. So what we have is different EPSG coordinates. So lot long, this is a 5703. I don't know which one it is. We also have a 26.8 something, which is Dutch. So this 1 point, so reference point 0, which is linked to this unnamed slab. This has multiple EPSG coordinates in multiple different reference systems. It also has this transform and position. The positions is just to show a point in the viewer. So this has nothing to do with the georeferencing. You can ignore it. It's just for the visualization. But the transform basically says this point, the transformed it from the 0 point of the slab to the middle, and then the EPSG codes say this is where this point is in different coordinate reference systems. That's really all you need. So if you do that for 2 points, yeah.
I'll let you finish.
If you do that for 2 points, you know where those points are on a map, and you can. I had the picture before. You can put it on a map. So this slab is placed on the Golden Gate Bridge. So if you import this in a tool that understands how to read these coordinates, it just projects these things. So we have, when you look at the example, there's this IFC5 example in the repository, but there's also an IFC4 example in the repository with the mapped projections. And the map projection is actually calculated from these points. So there's this scale factor, there's the 2D vector on how to transform it, because that's really all you need. So we did a proof of concept that these 2 points are enough to go back to 4.3 map projection, but it's really, in many tools, the only thing you need to get this data located at the right location.
So we have 2 points, 2 codes. So will the software will pick which one, or they always gonna report both of them? Because one will be I cannot see the number, but let's say we pick the one for the Netherlands, RDU.
Yeah.
So are we reporting it as a latitude and longitude, and that will be in just 84?
No, you can add whatever you want.
Okay.
So in this case, there's the same point at the same location has been reported here in 3 different reference systems. So this is lot long, and these are 2 others.
Yeah.
It's the same point, same location. I mean, there is a risk that the points are not synchronized, so the lot long resolved into something else than the others. Hope we have that problem all over IFC as well. But you can add multiple EPS keys, whatever kinds you want.
Okay. So Okay, so the vendors will just put all the APG codes that the user will input into this.
Yeah, yeah. If the user has that information, they would put it in the code they want.
Maybe a question for Esri then. What did user put in? 13 EPSG codes?
No, then basically is, okay, now for us will be, which one is the correct? Which one do we need to pick to put the geometry in the
Yeah.
right location?
Yeah, this is a returning topic. So these should all have exactly the same location. We have the same principle for the signals, which is the next one. The signal. So we say we have an alignment, and then every 100 meter there needs to be a signal, but every signal also has an XYZ coordinate on where it actually stands. So that needs to be the same as when you calculate it, 100 meters along the alignment, or the exact location needs to be the same. If it's not, then your data is invalid. It's the same here. These, if you have multiple EPSG codes of the same point, it needs to resolve as the same point. If it's not, your data is invalid. So in principle, if your data is valid, you can pick anyone you want.
So part of the system. I'm sorry, go ahead.
Oh, so then my question is, if we apply one of the rules for the validation, when we throw that, we'll just check, do we need to check, okay, if you're going from WTS 84 to our new, this is the transformation that you have to use. These are the values that will result for the X, Y, and Z in meters. Are we gonna do that? That will be basically, you will have to have all the transformation library on your side to be able to do that.
Yeah. No, most of these transformation libraries are available, but
Okay.
it's very similar to what I told before the break. I have an IFC file with a geometry that is 100 square meter slab, and then a property that says that it's 25 square meters. So it's invalid, inconsistent data. We have the ambition to put that into the validation service as this is invalid data. And we can do something similar here. I mean, you can check if these things are inconsistent. Same for the coordinates of signals. Are they calculated correctly? Because if someone changes the alignment, you also have to change the coordinates of the signals. If you don't do that, your data is invalid. So all of these data validation things are more software related.
And we're just thinking using EPGs, or are we use, maybe you can use the WCAD or.
Yeah, that's a really good question. This has been massively discussed. The reason why we ended up here, and I think before the lunch I already said this is not the best example yet because it has a namespace BSI georeferencing and then EPSG whatever. It's not a BSI standard. The EPSG codes are other standards, so they're published as PROSJ. So we want to refer to these PROSJ JSON publications as well, and then you basically you extend the core standard again, and people can choose whatever they want. And they also have these transformations into well-known text and other things. Yeah. So again, this is.
The tags that you have an example here, are they per object, or if I have a whole module that's using the same coordinate system, I specify that once. I don't have to specify it on every single point.
So that principle we're leaving behind a little bit, where you publish, where you define a reference system once for a whole file, because we don't really have files. A file is just a collection of different things. I mean, when people have a different opinion on the slab, it changes, or they have a different geometry on the side. So we needed to find a different solution. So what we have now is, when you look at this reference point, it's connected to the unnamed slab. So the unnamed slab is a relative position in the tree. So it's relative to the Golden Gate Bridge, my site, my project route. And the reference point has a transformation relative to the slab.
Okay, but it's still going to be extremely common that a whole collection of objects that are related to that Golden Gate Bridge, for example, or will use the same coordinate reference system.
Yeah, Yeah, if they're part of the same composition, people build on top of it, you have more geometry, you can still you map it in the same way.
Right, but I mean, the point, like, again, probably most projects are gonna have one system, right?
Yeah, I guess my concern is, so if I'm processing this file, I may end up having a whole bunch of transformations on the go at once rather than one transformation. It's just keeping track of the data as we're reading it is going to be complicated.
Yeah, I think the nice thing about the ECS approach is that you go over the whole file, the whole data set, so multiple files. You
Right.
skip anything you want, and you just look at where you find the PSG codes.
You need to attach trees to every, what is that thing?
No, in principle, you can put them whatever you want. I mean, we've now put them on the slab relative to the origin point of the slab. But as a user, when I don't know the exact point of the slab, but I have a point here, I can also create a point here that has the PSG codes to this point. And then use that.
You can position that one slab only with this, or can you position?
No. If I add the hello wall here, the hello wall would also come somewhere here. And then this is the hello wall is part of the whole composition with these two reference points. That should be enough to then put the whole composition on the map.
Why? Why would the wall be affected by reference points on a slab?
It's not. If you add the wall here, it would be probably, if it's the same GUIDs, right, it would integrate in the relative positioning tree. And you would just have more objects and more geometry in this composition. But still only two reference objects for the geospatial placements.
But then why does a reference point that is at the level of unnamed slab affect a wall that's at some other, the wall is also at the level of site or project?
Yeah, no. So the reference point doesn't affect the wall. The position of the wall in the tree is relative just as the slab. So
For the wall, better also have a reference point.
no. It has a reference point because it's a relative placement tree.
Yeah.
The wall is XYZ position.
Mhm.
So that's how it can be the same, in the vicinity of something that has been geographically located.
So whatever things you would import into this
Position?
yeah, would be moved to that place when you have those georeferences. So
Yeah, exactly. Whatever data you add to this composition, if you add it somewhere in this placement tree. So then it pops up here and
So if you had two
it's
slabs,
added.
if you had another slab like that would continue from this one,
Mhm.
then it would be also located on the map because
Yes.
yes.
Yeah. So you have the whole composition you see as you see it as Cartesian XYZ points. And then you take the two reference points of this Cartesian XYZ, and you use those two reference points to take that whole geometry set and scale it and rotate it on the correct location on a map.
Yeah.
And those reference points could just as easily be off of my project.
Yes. Actually, the P-short model we saw, I don't know where it is. The P-short model made the P-short model first, and then Jan Brouwer, who made this, saw the example of these reference points, and he added an additional file to say these are my reference points of the data that's in a different file. So he basically said he took one of this site, the Oxagon sites, and he said this corner of my Oxagon site is this EPSG position in a completely separate file. And as soon as you add that, you have your position of your whole data set of all of the 8 files.
So it doesn't have to be tied to the geometry, it can be just outside.
Yeah. Yeah, I think that's also very powerful because the user doesn't always know the XYZ location of the geometry. They know an XYZ location of some kind of a reference point somewhere outside of the building and the infrastructure. So, and that's usually also a starting point. When you start to create geometry, you have some reference points you import, and then you start to create a geometry on top of that.
That's important.
Yeah,
It's the naming, because I mean, if the name would be instead of slab, it would be a survey point or a base point. Then it would have
Yes.
exactly the same, but it would have the meaning for the user.
Yes.
What it presents, because it doesn't represent slab.
Yes, good. Yes, exactly. Well, actually, originally it was survey point. And I said, we're not going to call it survey point because that's confusing for users. Because a survey point is seen as something that is actually being surveyed by someone with a stick and then saying afterwards, and then saying this point is actually this XYZ. So I was actually the one that said it should not be called survey point, but you're right. Usually in an IFC community, people would refer to it as survey point. Yeah.
Yeah, okay.
Yes. Yeah, but that's indeed the principle. Yeah. Ah, that wasn't confusing. Interesting.
Does it still work when you put two data sets together that are carrying two different EPSG? I mean, which takes the prevalence between the XYZ placement and the EPSG? So if there are two very different projections and coordinate system, and each one of them is saying I'm 10 meters away from the origin of the file, then you bring everything together.
Let me check if I understand the question. If you say this, if you define this survey point, let's call it survey point, as in lat long, and you define this survey point in Arduino, differently you see. The question if it then
So when we have two data sets, so if that point is in one data set and it's
file or data set, what do you mean?
You have a campus, right? And every building is a separate ICX, right? Each one has its own local base point service.
Mhm.
So they're all at 000, right? And you put them all together, you get a bunch of buildings stacked up on top of each other because they're all 000.
Yeah.
Or are they probably offset from each other?
Well, yeah, depends on the viewer. Yeah.
But how do you? But in this case, you're saying if I brought another wall that didn't have any information, it would show up at the right place.
At 000.
Using that reference.
So yes, yeah. If you add a reference point to a composition, then yes.
But then there is an implicit rule that says when it's present, the geographic placement takes prevalence or override things like that.
No, I think this is the nature of this whole ECS setup.
Even that's what placement in the tree matters, right?
Yeah.
So if I had a campus, right, and each building had its own survey point, and you can imagine that the survey point is at a level, and the campus is underneath that level, saying, hey, this applies to everything underneath. If you can have that survey point anywhere, right?
Yeah, we're mixing up things. So if you have a campus with multiple buildings, so if you only have multiple buildings that start at 000, you don't have a campus. You have multiple buildings. If you all load them in the viewer, they'll all be stacked upon each other.
Yeah.
So if you want to position them relative to each other,
Mhm.
you can add one additional file that just places the origin point of the different sites somewhere else. Just with one file, you have them as a campus.
Yeah, but some might have that's the survey point. And no, that's not what.
No, that's not what it is. No, that's just a relative positioning. You're basically overlaying another tree for your individual files.
So are you still using this terminology of local coordinate system, or this is sort of similar to that? Like your example with the buildings. I have a building with a local coordinate system and a reference point. So that allows me to collect up all the buildings that each one has their own local coordinate system, but they all have a reference point. So I can collect them all together and I can use the reference points to place them correctly.
Yes,
in a world
that's
system.
what happens in a geo viewer. If you do that in a BIM viewer, they're all stacked upon each other at 0, 0. Well, I kind of have a feeling we need to look at this example as well, but we still have another day tomorrow. This one is also back online again. This is, I'm not sure if you remember, Joost, what's his name? made from. He was also in Budapest. He's not here because of the fear of fires. Remember him? He made this example in IFC5 from Wicca Hills, which is apparently a very famous open data set. Hong Kong, Singapore, somewhere. It's publicly available. He transformed that into IFCX. The nice thing about this model is that it actually has these boreholes as well. You don't see it in this geometry because of all of the other sites. But if you look into the details, you see IFC borehole. When you zoom into this, it actually is a borehole geometry with multiple parts for the different sediments. And he also has examples if you then go into it deeper. So this is the borehole, and then here these are siltstone basement and alluvium. Sorry, not a geoengineer. And so this is a really good example on how to do boreholes or geological models with IFC5. No questions? The hello wall you obviously saw as well. IFC Hero, I think, are you going to tell more about this later on? Or are you focusing on the Tekla house? Good. So I don't have to. The reason what I want to focus on here is this stainless steel column. I'll ruin your presentation as well again. So I think this is a good example of where we need a core extension. So the core currently is tessellated geometry. We need profiles and we need extrusions and all of these other stuff. I don't think it needs to be in the core, but it needs to be in a core extension. So I think this is a really good example at the moment that shows the capabilities of the core, but also a really good example that we can expand on for these core extensions later on. Linear placement. Yeah, again, this one is also from the beginning, I think over a year old now as well, updated to the latest version, of course, but this also really shows this new alignment and linear placement really nicely. Peter,
I tried to import that, and I think that doesn't follow the schema.
It could be that there's a minor update somewhere.
Yeah.
Doesn't follow which schema?
I think the OpenAPI schema. I mean,
I wouldn't be surprised if this rail and road update was not processed in this example yet.
Yeah, because they have something called linear placement, obviously.
Yeah, exactly.
That is not part of the schema.
Yeah, let's have a look. Like I said, this is a year old. Could be that that's a bit out of sync now with the latest schema. I think it is in sync, but let's have a double check. P-search, like I said, Jan put it online, and he has. See, this is an example where he's adding the georeference just as a separate file. So if you only load the georeference, you don't see any kind of geometry. But this is adding the data to certain points in this data set that you can then also see. Yeah, nice thing about this is also that he refers a lot to these external. I think he has examples where he uses a CCI classification system, analysis of B, fruits and vegetables. So it's a really rich example of a lot of different standards. The railway, yeah, also here, a lot of these alignment segments and linear reference systems.
Sorry, I had a question on the last one. If just pop back. So you said there was a georeference, a separate file for the georeferencing information, and then there's a whole bunch of other files like infra-bridge, infra-electric. Do they all reference back to that one georeference file? Is that how that's working?
No, so this is one. What you see here on the screen is one composition from all of the files you see on the left. So building architecture, building HVAC, building landscape, structural. So all of these start with an origin 000 Cartesian reference system, and they're not geolocated. So then, in a separate file, Jan has defined that certain GUIDs of the objects in other files have a certain geolocation. Does that make sense?
Yeah, I think so. I'm gonna have to look at it in more detail. Thanks.
Yeah, I think this is this principle of composition and an entity component system that really shows when you start working with it. Yeah.
Yeah, I want to see how they kind of related. It's kind of how you look at the data and understand it, and also how you would have generated that data in the first place. What concept you use to generate that data, to geolocate it correctly, and then reading it and understanding how to apply the geolocation.
Yeah. So that's why we're here, right? To
Yeah.
have a detailed look. Yeah.
Okay, thanks.
Yeah, so railway, again, I explained earlier as well that I think the linear placements can even be more normalized. We'll follow up with Sherasoft on this. Road to the same. Also, yeah, it's really good examples with this horizontal segment. Really interesting to look at. Tekla House, I'm probably not allowed to say this, but this is my favorite. Really, this is testing the boundaries of the viewer as well. My computer starts to slow down when I try to rotate this model, and very detailed. The nuts and bolts are yeah. Again, it's an amazing, really nice model, but also a good model for the next phases where we go into these extrusions and profiles. Tunnel excavation, as I said before, so these are these individual cuts per day. Sometimes they're a meter, sometimes they're a meter 10, sometimes they're 90 centimeters. Just throw them all into the viewer, and you have this composed scene. Yeah, so those are the examples that are currently online, which I hope to see back in some of your software tools. Any questions? Yes.
Transformation.
Ah,
So I'm able to make it right as I see on your screen. So I'm just curious how I would actually look at this one.
okay.
I
I haven't looked into the details of this model, and I can't show it in the viewer now because it doesn't work on Esri Wi-Fi. But that's interesting, yeah. But is it not not USB geometry?
The lead geometry. They have a transformation between
Ah, that I'll sit next to you later on. Yeah, let's have a look.
Okay.
Any other questions, comments?
Hopefully a quick one, promise. I noticed a lot of E to -17s and E to -16s and files to obviously zeros, right?
Yeah.
Is there somewhere a concept of the fact that they're zero and not, what points are close to each other or not? That happens anywhere?
Not at the moment. We should do that. Is it important for you?
I've seen errors in the past based on.
Ah,
Well, because again, it 10 to the -17th. But once you start getting to the 8, 7s, 6s.
For geometry?
Sure.
Ah.
Well, it was again, what's the same thing? What is it? And everyone has a slightly different.
Yeah. Okay, but that's when you try to import someone else's data in yours, and then try to change it. Yeah, again with this, the whole principle of this ECS layered approach is that you just don't change someone else's data, and you can have a different opinion, and you set it to 0, and someone can accept it or not.
But even like what's watertight and not. That's probably the biggest thing, right? What constitutes versus what's a surface bond.
Yeah, okay. And in simulation.
Then there'll be some difference where you'll say, no, there's a teeny little hole here, versus same thing.
But interesting, right? Because if there's a teeny hole, then someone has to fix that and regenerate the actual 0.
unless you think that's the same thing. Again,
Let's put this on the agenda for discussion. Yeah.
there could be a 10 to the minus 17. So
Yeah.
yeah,
Yeah. I know. Yeah.
less than. But anyway, I didn't want to go too, but it's not. That's I think that can trip up some of these things if we don't have some agreement of.
Yeah.
Tolerance.
Let's put that on the agenda. Maybe have time for tomorrow, and otherwise, that next one of the next meeting. All right. Any questions? Yeah, the last comment I have is that I'm amazed by how much active people we get creating actual example files, because these are only the ones that we are allowed to publicly share on GitHub. But I've been getting a lot more. Also, the Canadian bridge example. I get amazed almost every week by how easy people seem to be finding it to generate this, how easy it is to implement, and also with the excavation model, with the point clouds, the use cases people invent with this are, were beyond my imagination. So I hope you will share that feeling as well at some point, because I also need some validation on this. But I think developing a new standard, having so much community input already is a good sign. So maybe I'm shooting myself in the foot by opening up to you now for presentations, and you'll say it's way too difficult. But I really have a good feeling on this. So I do hope that we can start the ISO procedure and get this course standardized pretty quick. All right. Questions, comments?
Notice that the pieces, at least the architectural file, seems to be in millimeters.
I won't comment on that. Do you want to present? Do you want to go after you?
Yeah.
If we still have time, because usually when Pasi presents, then we have big discussions.